All right, welcome everyone to another deep dive. Today, we're going to be talking about something that I think is really cool, and that is fine-grained reactivity with signals.
Yeah.
Um, we've been looking at a presentation on this, and we have some demo scripts.
Right.
One is just showing like basic signal implementation, and then another one is like inside of Angular's rendering.
Yes.
And we also have a Q&A document with some common questions answered.
Yeah, some good questions in there.
Yeah. So hopefully we can really get into it and break it down.
Yeah.
So yeah, our goal today is to just like understand what signals are, like how they work,
Right.
you know, kind of under the hood, why everyone's so excited about them, especially when we talk about performance.
Right. Yeah, performance and just like developer experience.
Right. Yeah, right.
Making things a little simpler.
Yeah.
And the idea is to really get to that aha moment of like how signals allow only the necessary parts of your UI to update.
Right.
That's the big thing. Only what needs to be updated gets updated.
Exactly.
So,
So yeah, let's start with kind of a relatable problem that I think a lot of people have run into, and one that I've run into personally.
Yeah.
And you're debugging an app, and you find out that like you change some like minor visual thing, like a button hover color or something, and like the UI re-renders.
the whole thing just blows up. Yeah.
Yeah, which is, you know, not great for users.
Yeah.
And a huge pain to debug, like where's the bottleneck? Why is this, you know?
Absolutely. And I think that frustration is really like what's driving a lot of this move towards signals.
Right.
Right? Because traditional reactivity, while powerful,
Yeah.
can sometimes be the cause of that.
Right.
These really broad, inefficient updates that just make everything slow and janky.
Right.
So signals, they offer a fundamentally different approach.
Okay.
And you can think of a signal as like a special kind of variable
Okay.
that knows about its dependencies. So when its value changes, it only notifies the things in the UI or in your application logic
Right.
that are actually using it.
Okay.
So you avoid these massive re-renders that can really slow things down.
Right.
And it also just makes your code like way easier to reason about
Right. Yeah.
because you know exactly what's going to be affected.
Exactly. Yeah. If you have a problem, you can isolate it more quickly.
Absolutely, yeah. Much more maintainable.
Yeah.
Yeah.
So it sounds like a big improvement.
It is, yeah.
But is this a new idea?
No, not at all.
Okay.
The ideas behind reactive programming, they've been around for a long time.
Oh.
Like we're talking decades, like even back to the 60s
Wow.
with like early work on like spreadsheet calculations and stuff like that.
Okay.
And then more recently, like in the front-end world, we had frameworks like Knockout.js,
Right.
which came out around 2010,
Okay.
and then MobX in 2015.
Right.
Both of those are kind of using forms of observable reactivity.
Okay.
So the term signals really started to take off probably around 2017 with SolidJS,
Okay.
which kind of made signals like the center of its architecture.
Okay.
And then in 2020, Vue 3 came out with the composition API.
Right.
And its ref function is also very signals-like.
Okay.
And so now we're seeing even like the really big frameworks like Angular and Svelte
Right.
are adopting signals.
Right.
So it's not a brand new idea,
Right.
but it's really starting to become very, very popular.
Yeah, it's interesting
Yeah.
how like these patterns emerge, and then some things take off and some things don't, and then like yeah, they get adopted, I guess, as they
Right, as they prove themselves.
prove themselves. Yeah.
Right.
So when we talk about traditional reactivity versus signals, we often hear the terms coarse-grained and fine-grained.
Right.
What do those mean in practice?
Yeah, that's a really good question.
Like,
Let's go back to our spreadsheet analogy. So coarse-grained reactivity would be like if you change one cell in a spreadsheet,
oh, okay.
the entire spreadsheet recalculates.
Yeah.
Even the cells that have nothing to do with that change.
Right. Right.
Right. Like everything has to update.
Right.
Fine-grained reactivity is like if you change that one cell,
Okay.
only the cells that are directly dependent on that cell will recalculate.
Oh, okay. Okay. So just like the dependent stuff.
Exactly. Yeah.
Okay. Okay. That makes more sense now.
Yeah, it's a much more precise.
Yeah.
Right.
Yeah.
You're not wasting time recalculating stuff that doesn't need to be recalculated.
Right.
Yeah.
So we have a demo that kind of illustrates this inside of Angular.
Yes, we do.
Can you walk us through that a bit?
Absolutely.
What does that show?
Yeah. So this Angular rendering demo
Okay.
really shows the difference between these two approaches.
Okay.
So on the coarse grain side,
Okay.
We have an example that uses Angular's traditional change detection, which often involves Zone.js
Right.
and the EngdoCheck lifecycle hook.
Right.
So we have this component called outer counter component,
Okay.
and it just has a simple count property,
Right.
just a number.
Right.
And when that count changes, like let's say a button is clicked,
Okay.
Zone.js picks up on that change.
Right.
And it triggers change detection not only in that component,
Okay.
but potentially in its entire subtree of components.
Okay.
And in the demo, it's really cool because it visually highlights what's happening.
Okay.
So there's this other component called unrelated element component,
Okay.
which doesn't even use the count.
Okay.
It's totally separate.
Okay.
And there's also inner counter component, which receives the count as an input.
Okay.
But even the unrelated component, when you click the button to increase the count,
Yeah.
it gets rechecked.
Right.
And its borders flash.
Okay.
Even though it has absolutely no reason to update.
Interesting, yeah.
And it's the same with the inner counter component.
Okay.
It receives the count.
Right.
So it does need to update.
Right.
But everything kind of flashes red
Right.
when you click that button.
Right. So it's like, it's not really smart about like, okay.
No, it's just like something changed, everybody panic.
Yeah. Right.
Yeah, that makes sense.
So that's kind of the old way of doing things.
Okay.
Now, on the fine-grained side,
Okay.
we have the same basic setup,
Okay.
but we're using Angular signals.
Okay.
So the outer counter signal component uses signal 0 to create its reactive count.
Okay.
And when you click the button, it calls count.update,
Okay.
right?
Yeah.
But the key difference here is that there's no EngdoCheck involved.
Okay.
So there's no broad sweep to check everything.
Okay.
Instead, only the things that are explicitly connected to that count signal
Right.
are going to react.
Okay.
So the inner counter signal component also gets the count as an input,
Right.
but it uses an effect.
To subscribe to changes in the signal
Okay.
and highlight itself when the count changes.
Okay.
But the unrelated component, because it's not connected to the signal at all,
Yeah.
remains completely untouched.
Okay.
So when you run this demo,
Yeah.
you see that the outer and inner counters highlight when you click the button,
Right.
but the unrelated element stays exactly as it is.
Oh, okay.
It's a much more targeted and performant update.
Okay. That makes sense. So it's really only updating the things that are directly connected
Yeah,
to
exactly.
that. Yeah. Okay. That's cool. So the demo script also talks about two-way binding with signals in Angular.
Right.
Is that something that's just automatically handled?
It's a little bit different with signals.
Okay.
So Angular signals promote like a unidirectional data flow,
Okay.
which means that to achieve that kind of classic two-way binding,
Right.
where like changes to an input field, update the component.
Right.
Changes to the component,
Right.
update the input field. You have to be a bit more explicit in how you set things up.
Okay.
So the demo has an example where you might have a name signal
Okay.
and an update name method
Okay.
that updates the signal based on what's typed into the input.
Okay.
And then in your template, you would bind the input value to the signal
Okay.
using value name.
Okay.
And you would use input update name
Yeah.
to handle the input event and update the signal.
Okay.
So it's a little bit more manual,
Right.
but it gives you more control
Okay.
over exactly how that data is flowing.
Okay. Yeah, that makes sense. So we've seen how signals work at a high level in Angular.
Right.
Can we kind of dive a little deeper into like how they actually achieve this?
Absolutely.
Like how does this work under the hood?
Yeah. So for that, let's look at the basic signals implementation demo,
Okay.
which really gets down to the nuts and bolts.
Okay.
So the core of it all is this signal
Yeah.
function. Right.
Yeah.
At its heart, a signal is just an object that holds a value.
Okay. Yeah.
But it's more than just a regular variable.
Okay.
It has these internal mechanisms for keeping track of
Okay.
who's interested in its value,
Okay.
who are its subscribers,
Right.
and then when the signal's value changes,
Yeah.
it notifies those subscribers so that they can update themselves,
Okay.
right?
Yeah.
It only notifies the things that actually need to know.
Right. So it's very targeted. Yeah.
Exactly. It's not this like global announcement.
Right. Sure.
Right? It's like, hey, you three, you care about this. Here's the new value.
Right. Yeah.
Right.
Yeah.
So that's kind of the magic of it.
Yeah.
And that's where the effect function comes into play.
Right.
So the effect function is how we handle side effects,
Okay.
like updating the DOM, logging stuff,
Right.
triggering other actions
Okay.
in response to changes in the signals.
Okay.
So you define an effect,
Okay.
you give it a callback function, and then The really cool part is that if that callback function reads the value of any signal,
Yeah.
that signal automatically becomes a dependency of that effect.
Oh,
The system is smart enough to figure that out.
okay.
It says, oh, this effect is using this signal. I need to make sure that this effect runs again
Right.
when this signal changes.
Okay.
So there's this concept of a current running effect,
Okay.
which is a way for signals to keep track of which effect is currently active.
Okay.
And that needs to be subscribed to.
Okay.
Right.
Yeah.
So all of that dependency tracking happens automatically,
Wow. Okay.
right?
Yeah.
You don't have to manually say, this effect depends on this signal, and this effect depends on that signal.
Right.
You just write your code the way you normally would.
Right.
You read the signal values you need,
Right.
and the system takes care of the rest.
That's so cool. Yeah.
Like, yeah.
Okay, that makes sense. So what about like derived state? Like if you have a value that's based on other signals.
Yeah. Yeah, that's where computed comes in.
Okay.
So a computed signal is essentially a read-only signal
Okay.
whose value is determined by a compute function
Okay.
that you provide.
Okay.
And that compute function can use any number of other signals as inputs.
Okay.
So whenever any of the signals that the compute function uses changes,
Yeah.
the computed signal will automatically reevaluate
Okay.
and update its value.
Okay. Cool.
And under the hood, it's actually using an effect
Okay.
to track those dependencies and update itself.
Okay.
Right.
Yeah.
So computed signals are really useful because they help you keep derived values in sync
Right.
without you having to manually update them every time.
Right. Yeah, that's awesome.
Yeah.
Okay, cool. So the demo script for this basic implementation, it also has like some examples in an index.js file.
It does, yeah.
What are those?
Yeah, so it shows like a very simple counter
Okay.
where you have a signal that holds the count value and in effect that updates a display element every time the count changes.
Okay.
Right.
Yeah.
And then it has an example of a computed total.
Okay.
So you have like a price signal and a quantity signal,
Right.
and then a computed signal that calculates the total price.
Right.
And it updates whenever either the price or the quantity changes.
Okay.
And then finally, it shows that two-way binding example we talked about,
Okay.
where you have an input that updates a name signal
Right.
and an effect that keeps a display element in sync with that name signal.
Right. Okay. And then all of that is like, updating in the browser in real time.
Yeah, it's all live in the demo.
Right. Okay. Cool. So we've seen how signals work in Angular and in this like basic implementation.
Right.
How do signals fit into the broader ecosystem?
Yeah, good question.
Like, are all frameworks doing this the same way?
Well, the core concepts are pretty much the same,
Okay.
but different frameworks obviously have their own implementations.
Right. Right.
So SolidJS was like a very early adopter of signals.
Okay.
They have create signal, create effect, and create memo.
Okay.
And it all has that automatic dependency tracking we talked about.
Okay.
React is a little bit different.
Okay.
They have use state, use memo, and use effect.
Right.
And they tend to be a little bit more manual
Okay.
in how you set up those dependencies.
Okay.
You have to like explicitly list them in dependency arrays.
Right. Right. Right.
But even within the React ecosystem, there's a movement towards more automatic dependency tracking.
Okay.
So you have libraries like Jotai, Valtio, and even the experimental React's Forget compiler,
Okay.
which is trying to like automate a lot of that dependency tracking.
Okay.
Svelte is kind of in its own category.
Okay.
It operates a lot at a compilation level.
Okay.
So you declare your reactive variables with let,
Okay.
and then uses this double block syntax for both computed values and side effects.
Okay.
So it's like all baked in at build time. Vue has refware for reactive variables, computed for derived state,
Oh.
and then watch
Oh.
and watch effect for side effects.
Right.
And that's all automatic dependency tracking as well.
Okay.
And then Angular, obviously, as we talked about, has its signals computed in effects.
Right.
So even though the syntax might be a little bit different,
Yeah.
across all these different frameworks, the underlying concepts are really similar.
Yeah, that's what's interesting is it's like everyone's converging on this idea, but doing it in their own slightly different way.
Right, exactly.
Yeah, that's cool. So another question that often comes up is the relationship between signals and RxJS observables,
Yes.
which, they both deal with reactive data.
Right.
So what are the key distinctions?
Yeah, that's a great question, and it's something that comes up a lot.
Yeah.
The Q&A actually addresses this directly.
Okay.
The main difference is in their focus.
Okay.
So signals are really about state.
Okay.
They hold a current value, and when that value changes, they notify their dependents.
Okay.
It's a pull-based model.
Okay.
So
Yeah.
you can ask a signal for its current value whenever you want.
Right.
and the dependency tracking is automatic.
Right.
Observables, on the other hand, are about streams of events.
Okay.
So it's a sequence of values over time,
Right.
like user input,
Right.
or HTTP responses,
Right.
or WebSocket messages.
Right.
Right.
Yeah.
So they're push-based.
Okay.
They send values out to their subscribers as those values become available.
Okay.
And the subscriptions are usually explicit.
Okay.
So you have to say, I want to subscribe to this observable.
Right. Yeah.
The Q&A has a nice way of putting it.
Okay.
It says signals answer the question, what is the current state?
Okay.
And observables answer the question, what happened over time?
Okay.
So signals are great for managing like local component state,
Okay.
while observables are really good at handling like asynchronous operations and sequences of events.
Right.
And it's also important to note that they're not mutually exclusive.
Okay.
You could use them together
Right.
in the same application.
Right.
So you might have a signal that's derived from an observable,
Okay.
or you might use an observable to update a signal.
Okay, cool.
Right.
Yeah, that makes sense. So what about all the state management libraries?
Right.
Like NGRX, Redux, that kind of thing.
Yeah.
Does this mean that those are all going away?
I don't think so.
Okay.
I mean, signals are really great for managing like local state, relatively simple state.
Right.
But when you have a really large application,
Yeah.
you often need more structure.
Right.
And
Right.
that's where these state management libraries come in.
Right.
They provide things like explicit actions,
Right.
immutable state updates,
Yeah.
dedicated developer tooling.
Right.
All of that stuff is really important for managing complex applications
Right.
and making sure that they're predictable and debuggable.
Right.
And signals don't really provide any of that stuff out of the box.
Right.
So I think state management libraries are here to stay,
Okay.
but I do think that signals might influence how they work.
Okay.
For example, we're starting to see some exploration of exposing store state as signals.
Okay. Interesting.
So you could potentially have like a NGRX store
Yeah.
where the state is exposed as a signal,
Okay.
and then your components could just consume that signal directly
Right. Right. Right.
without having to go through all the selectors and stuff.
Right. 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 Okay. That makes sense. Yeah.
Yeah. So it's an interesting area to watch.
Yeah. Cool.
I don't think state management libraries are going anywhere,
Right.
but I do think that signals are going to have an impact
Right.
on how they evolve.
Okay, cool. So just to kind of summarize,
Yeah.
we have this core concept of reactive state,
Right.
which is managed by signals.
Right.
And then we have computed values,
Right.
which are derived from that state. And then we have side effects,
Right.
which react to changes in that state.
Right.
And these seem to be like really fundamental building blocks
Yeah, absolutely.
for modern JavaScript frameworks.
Yeah. I mean, every major reactive JavaScript framework
Yeah.
is built on these concepts.
Right.
Whether it's Angular signals, view refs, Svelte reactive variables, React hooks.
Right.
They're all about managing observable state, computed values, and side effects.
Right.
It's really like the core of reactivity.
Right.
Yeah.
So for our listeners, like for .NET and web developers out there, why should they care about this?
Oh, there are so many reasons to care about this.
Okay.
First of all, performance.
Okay.
Signals have the potential to dramatically improve the performance of your applications by only updating what absolutely needs to be updated.
Right.
You can reduce CPU usage, make your UIs smoother, more responsive,
Right.
especially in large applications.
Right. Yeah.
Second, maintainability.
Oh.
The code you write with signals tends to be much easier to understand and reason about
Okay.
because the data flow is so explicit.
Right.
You know exactly what's going to happen when
Right.
a signal changes.
Right.
And finally, scalability.
Right.
If you're building really large enterprise-level applications,
Yeah.
especially in the Angular world,
Right.
signals offer a path to building UIs that are more performant and manageable.
Right. Okay.
So there are lots of reasons to be excited about signals.
Yeah, and it sounds like there's even a proposal to bring signals right into the JavaScript language itself
There is, yeah.
as like a standard.
There's a TC39 proposal that's currently in the early stages,
Okay.
exploring the standardization of signals at the language level.
Okay.
And obviously these things take time.
Right.
But the fact that so many major frameworks are already using signals
Yeah.
really gives this proposal a lot of weight.
Right.
And if it were to be adopted,
Yeah.
it would just make reactive programming a lot simpler.
Right.
Right. Across the entire JavaScript ecosystem.
Right. Yeah.
Because we would all be working with the same basic primitives.
Right.
So yeah, it's definitely something to keep an eye on.
Yeah. That's cool. So the main takeaway is that signals update only what's needed.
Absolutely.
leading to better performance, better UX.
Yeah, it's all about efficiency.
Yep.
Making sure that we're not wasting resources updating things that don't need to be updated.
Right.
Yeah.
Awesome.
Yeah.
So as we wrap things up here, is there a final thought that you want to leave our listeners with?
Yeah. I would just say, think about your own projects.
Okay.
What are the performance characteristics of your applications?
Okay.
How might this idea of fine-grained reactivity
Right.
with signals impact your work?
Right.
Could you make your applications faster, more maintainable, more scalable?
Right.
I would really encourage you to explore the resources
Okay.
that we mentioned in the presentation.
Right.
There are links to some great introductory guides. There's the TC39 proposal.
Okay.
There's the official documentation for Angular signals and SolidJS.
Okay.
And I would especially recommend checking out the demos that Javi Karian created.
Right. Right.
They're really well done.
Yeah.
They really show you how signals work in practice.
Okay.
So yeah, I would encourage you to go check those out.
Yeah.
And just play around with signals.
Right.
Build a small demo app.
Yeah.
Get a feel for how the data flows,
Right.
how updates propagate.
Right.
I think you'll be impressed with how much more efficient,
Yeah.
how much easier it is
Yeah.
to build reactive applications with signals.
Awesome. Well, thank you so much for joining us for this deep dive.
My pleasure.
I think this was really insightful.
Thank you.
I hope you all found it valuable and that it sparked some curiosity
Yes,
about signals and reactivity.
absolutely.
So yeah, thanks again.